Hello guys, welcome back to my YouTube channel. In this video, we'll discuss about the force vector. In the previous video, we discussed about the forces. Now, let us discuss about the force vectors. Now, what is a vector? A vector is a quantity that is completely specified by its magnitude and its direction. Okay, definition of a vector is a quantity that is completely specified by its magnitude, that's the amount, and the direction. Okay, now in order to study about the force vectors in a biomechanical analysis, we need to know about the four important factors. What are these four important factors? The first one is the point of application. Okay, the second is the direction, and the third is the magnitude, and the fourth is the spatial orientation. Now let us see the point of application. The point of application of a vector is where the base of a force vector contacts the body segment. What does it mean? Now let us see this diagram. This is a vector. Okay, this represents the base where it contacts with the body segment, and this represents the shaft, and this arrow represents the direction. Okay, these are the three important factors considering with regard to that of the point of application. Now the base of a muscle force, or the point of application of a muscle force is represented where the muscle inserts into the bone. For example, if you take this segment, that is the humerus, this is the humerus, and this is the ulna and radius. This is the biceps brachii muscle. This biceps brachii muscle inserts into the radial tuberosity of the radius. Now, the point of application of the muscle force is where the muscle inserts. This is the point of application. Okay guys, this is the point of application of a muscle force. And the point of application of an external force depends on whether the result of the force is from the gravity or whether the result of the force is from the resistance applied by some means of physical contact. Okay, this is the base, and with respect to point of application, with respect to muscle force, with respect to external force. And what is angle of insertion? The angle of insertion is the angle formed between the tendon of a muscle, this is the tendon of a muscle, and the long axis of the bone. Here, the angle of insertion of a biceps brachii is about 90 degrees when the elbow is flexed to 90 degrees. And the angle of insertion keeps on changing as the elbow flexes and extends. In this example, the angle of insertion is about 90 degrees with respect to when the elbow is flexed to 90 degrees. Okay, now let us see the second important factor, which is known as direction. The direction of the force vector is indicated by the arrowhead. Okay, for example, if you take this, this is the direction of the force vector. For example, if you consider this as an external force like gravity. Okay, now this is the direction of the arrowhead. In this direction, in downward direction, it is acting. Whereas if you take this muscle force, this is the muscle of, for example, it's the biceps brachii, it is acting in this direction, it is considered as an internal force. Okay, this direction is indicated by the arrowhead. In which direction the arrow represents, in that direction the force vector is acting. In this direction downwards, it is an external force such as gravity is acting, and this is the muscle force which is acting as an internal force. Now if you plot in a graph, let us take the same thing here. For example, if you consider this as a y-axis, positive y-axis, and this as a negative y-axis. Now keep this internal force, for example, in this example it is acting in the upward direction. So if you take this here in this direction, and the external force in this direction, so the external force is acting with respect to that of the negative y-axis, and the internal force is acting with respect to that of the positive y-axis. Okay guys, this is all about the direction of the force vector. Now let us see the magnitude. What is magnitude? It is indicated by the length. It is indicated by the length of the shaft of the arrow of the force vector. What is this? Now let us take this example, indicated by the length. This is the point of application, this is the shaft. Okay, this whole thing from here to arrowhead is the shaft. The length, how much length of this force vector is the magnitude of that force. Greater the length of the force vector or the shaft, greater the magnitude of the force. Okay, now what is the spatial orientation? Spatial orientation is indicated by the position of the shaft of the arrow. What is the position? The position may be vertical, the position may be horizontal in that spatial orientation, and it is also defined as the angle formed between the shaft of the force vector and the coordinate system. For example, if you take this, if this is the shaft. For example, if you take here, this is the shaft, and this angle formed between the spatial coordinated system and the shaft of the force vector can also be represented as a spatial orientation. Now, if you take this example, the leg foot segment, this is the weight board, okay, and this is the leg foot segment. This is the leg foot segment, and this is the weight boot. Now, in this, the weight boot contacts the leg foot segment and forms a pulling force and creates a pulling force in the downward direction, and this force vector is represented as weight boot leg foot segment. For example, the amount or the magnitude of the force acting here in a downward direction is about 40 newtons. Okay, and this creates the pulling force, and the point of application is very close to the pulling force, and the magnitude is the shaft, and the direction is represented in a downward way. Okay, so this is all about the force vector, guys. Now in this video we studied about what is the definition of the vector and what are the 4 important factors to study about the force vectors with respect to that of the biomechanical analysis, that is the point of application, direction, magnitude, and the spatial orientation. Thanks for watching this video, guys. Thank you very much. Please subscribe to my channel, share, like. If you have any doubts, do comment, guys. Thank you.